All right, so today, or right now, I'm going to do this problem. This is homework 10. It's got a nice grid lines out there for us, so the expectation is we're going to use them. So this one, you didn't really have to do the given and required so much, but you know, you got to draw this thing right here, right? So not everybody's on the homework. You kind of got to draw that because that's what you're working off of. Okay, so to get started, the first thing we're going to do is we're going to draw some vertical lines wherever anything interesting is going on here. So here's a vertical line at 10, at 0 meters. Here's one at 15. Here's one at, this 20 kilonewton moment. And here's one at the beginning of this 10 kilonewtons per meter. And then last we have one at the end here. Okay, so the graph paper really helps with this sort of thing. Yeah, so you can expect on your final you will have graph paper. Sorry for my squeaky chair. Okay, so right here we're going to do the shear first. And I'm going to go ahead and put the units over here at kilonewtons because that just makes my life easier. And so I'm just going to do whatever the diagram above it tells me what to do. Okay, so I'm going to go up 10. Let's see, what do we want to make 10? Let's go ahead and make 4 boxes will be 10. Okay, because I'm just kind of doing what this tells me to do, right? And then I'm going to stay at 10. Okay, because it doesn't tell me to change anything, so I'm just going to stay here for a bit. And then all of a sudden I'm going to hit a 15 down. So I'm going to do what the 15 down tells me to do. I'm going to go down 15. Okay, right down to here. Go ahead and label this. This is 10. Okay, and then so now I'm down. I went down 15 from a positive 10, so now I'm at a negative 5. So here I am at negative 5. Okay. Now note there's a moment right there, but there's not a shear, so we're going to ignore it. And we're just going to keep going to the left, to the right, until we get here. Okay, at which point we're going to go down 10 kilonewtons per meter. So every meter to the right we go, we'll go down 10 kilonewtons. Okay, so total we're going to go down 20, because we're going to go down 10 per meter for 2 meters. So we're going to go down 20, so we're going to end up at negative 25. So let's see here, that's here, that's another 10, right? Oh yeah, I shouldn't have made these markings so so small. So we're going to go down here, so that's a grand total of a negative 20. Okay, so we're going to go down to here, right, we went down 20, but we started at negative 5, so we went to negative 25. Okay, and then right here, we're going to go back up 25 kilonewtons. So we're going to go like this. Okay, and that's a good sign. So like in a lot of these, they won't necessarily solve for the reactions for you, but you should always end up at 0 on the ends. And if you don't, then you have made a mistake. Okay, so the typical thing to do is to kind of shade these in. I'm actually just going to write the areas in there, and then I'll shade them in afterwards. So the area of this rectangle is 10 by 2, so this is 20 is the area. Let me do that in a different color. Let's do that in red. 20. Okay, the area of these rectangles, let's see, negative 5 times 1 is 5, a negative 5. And then this rectangle is a negative 5. And then of this trapezoid, or whatever we call this shape, well, basically the way I think of this is I go, well, what is the average height of this thing? Right, well, it's 25 on one side, and it's negative 5 on the other, so that's an average of 15. So I take that 15 and I multiply it by 2, and I'm going to get a negative 30, okay, for the area of that trapezoid. Okay, and so that's kind of how we do it. Now I'll shade it in. Okay, this is just going to, these markings will just help me. So those are the moments imparted by these shears. Okay, so there you go. So that's the shear diagram. Okay, now let's go down here. Let's do the moment diagram. My guess is most of this one's going to be positive. So I've kind of worked myself into a bit of a corner here space-wise, but we'll just do the best we can. Okay, so let's see what we can do here. Okay, so let me take this eraser and clean that up a little bit. We'll do moment, and that's in kilonewtons times meters. Okay, and I'm going to extend my lines a little bit, and I'm just going to pray that I don't need that much more space here. Okay, I think the moment's mostly going to be positive, so I think we'll be okay. Okay, I don't think we need this negative space. Okay, so we're going to start here. We've got this, okay, we've got these, I'm going to do this in red because it's going to apply to these moments that we have right here. Okay, and the first thing I'm going to do is I'm going to go up 20. So let's, I guess I can be pretty aggressive here. Let's see if I wanted to make 5, 10, 15, 20. I don't think that's going to create a problem. Okay, so we're going to go up to 20. It might create it's not going to create a problem. I don't know if it's going to create a problem. I guess we'll find out, okay? So basically this is the 10 times the 2, okay, to give me this 20, so that's how much I went up. Now notice it's a constant rate of going up because I'm adding these little boxes as I go, and each little box has the exact same value. So each little box is kind of kicking me up the same amount, so I get a constant rate of rise. Okay, so this gets me up to 20 kilonewtons times meters. Okay, and now I'm going to go down 5 because I've got a little, red, that's the area of that box. So I'm going to go down 5 because that's going to put me about here. Again, this is why you need a straight edge for this. So that's going to put me at 15. Okay, and this is kind of the unusual spot right here. And we're hitting this particular moment. And we hit this moment, and our tendency is to think of this as a positive moment, because it's going clockwise, right? Excuse me, it's because it's sorry. Our normal tendency is to think of this as a negative moment because this moment is going. So, just for reference, we're thinking about this moment right here. Okay, it's 20 kilonewtons times meters. And what's happening is, so our normal tendency is to think, okay, well, this thing's going clockwise, so it's negative. But really we want to think about what its effect is on the remainder of the beam. And so on the remainder of this beam, so if I'm looking at just this section of the beam over here, okay, then this counterclockwise moment is doing this, okay? And so that means that basically what it's causing this thing to do is it's causing this thing to bend this way. So it's causing the beam to smile. So if it's causing the beam to smile, it's considered a positive moment. Okay, so this thing, even though it's clockwise, and so we really want it to be a negative moment because of that, we have to think about what it's going to do to the right-hand side of the beam. Okay, so in this case, the right-hand side of the beam, because we're working left to right, is causing it to smile. So we're going to work it that way. Okay, so this thing is 20 kilonewtons per meter, and because it's making it smile, we're going to go positive by 20. Okay, so we're going to go 5, 10, 15, 20. Woo! Got really tight there, right? So we're really kind of getting into the shear space. Okay, don't do so bad of a job as I just did. Okay, so now we're up to 35 kilonewtons times meters. And then, so then we need to go, let's see here. So we need to go down 5. Again, that's the area of this box right here. So we're going to go down 5, like this. Okay, so it's going to put me at 30. Okay, and then notice, and we should be very happy about this, this is negative 30, so I'm going to go down 30 over the ensuing distance. And then note that the bits that I'm adding at first, like I'm subtracting some right here, and I'm subtracting big amounts here. So what's going to happen is we're going to this is going to be concave down, so it's going to look like this. Okay, in this case, this transition right there at number 30 would be smooth, but So anyway, so that's how you do it. Let's see. So yeah, it goes back down to 0 again. If you don't end up at 0 at these points, you made a mistake. Usually we, highlight it in. And if somebody says, well, what's the max shear? If they say, well, what is the shear max? And they usually want absolute value. And if they said they want the moment max, well, you would just look at your diagram. Okay, in this case, the max shear is negative 25, okay, kilonewtons. Or I guess it's absolute value, so sorry. So that's just a 25 kilonewtons. And the the max moment is going to be that 35 kilonewtons times meters. which kind of tells us if we go up to this thing, you know, where would this thing fail due to shear? And it's going to fail right here at the end. Okay, and where is it going to fail due to the moment? And that will be right here. Okay, so those are the spots that you really want to check and make sure that your beam can hold. Okay, so that's it. Anyway, hope you find this helpful. All right, later. Bye.